Okay, so last time we were talking about how strike-slip faults can also form at these. Mostly, they can form at both oceanic and continental divergence. But basically what happens here, let's say we have let's go over here and have a boundary here and two boundaries, a divergent plate boundary where this is going apart here and this one's going apart here. But let's say they're going at different rates. Let's say this is going at 10 centimeters per year and this one up here is going at 7 centimeters per year. Okay, if that's the case and this one's going slower than this one, what ends up happening is there a fault forms in the middle. Sometimes we call these transform faults. It's a transform boundary, but the better term for it is what we call a strike-slip fault. Right? Okay, and so we can even know what kind it is. So if we actually looked across this one, if I was here and looked across the fault, this block here would look like it's going to the right, so this would be a right lateral transform fault. Even if I looked at this way and then looked at the other direction, it still looks like it's moving to the right, and so that's why we'd call that right lateral. So anyways, so those happen also at oceanic divergence and continental divergence, but their most common fault at a divergent plate boundary is normal, by far, because that's the tensional that's forming. Okay, now at transform boundary, you have what we call shear stress, right? Okay, the shear stress means that it's going apart from each other. Let's kind of zoom in here, going past each other. These are what we call the strike-slip faults that are occurring here. And remember, you can have two different types of strike-slip faults. You can have one that, let's say this is a road here, and there's the road here on this side. And so you'll notice that this one here is what we call a right lateral. So if I was stepping on this side and looking across, everything looks to the right, so we'd call this a right lateral. If I have a same fault, this is strike-slip as well. But this time, oh, I messed up. Let's do this. Okay, so it looks like now it's moving this way, and this one's moving this way. So now this is what we call it. If you look across again, it looks like to move to the left, so we call this a left lateral. Okay, those are the two different types of strike-slip faults we have. This is looking from a plane view, so looking down from like an airplane looking down, whereas the other ones were looking at it from a side view, right? So it's going up and down, whereas these ones are going horizontal. So anyways, so transform faults, these guys are fairly straightforward. Because there's this motion going back and forth, underground there is no increase in temperature, no increase decrease of pressure or anything, so we have no volcanoes at these boundaries. Okay, and you can have transform faults forming in oceanic crust or continental crust. I'm not making the different designation of the difference here because they're pretty much the same. They don't have really much relative differences with them. Whereas because of the two different types of crust, you have different types of lavas and different types of volcanoes. That's why we classify those ones as different. Transform is pretty much the same because there's really not much difference between the two. No volcanics at these here. They tend to have lots of large earthquakes. Okay, anywhere from 6s, which are good, pretty good size, all the way up to maybe a 7. That's about 7, maybe even an 8 if you're lucky. I won't say if you're lucky, but if 7 and 8 maybe is maybe the maximum that you'll usually get at a strike-slip fault. Okay, so those are the ones that you have here. At these settings, you can have metamorphism, but it's really rare. So it's a rare metamorphism, and it's really just right at the faults that you would have them. So it's really not that big. So not much going on here. But so not very many geological resources specifically related to the system itself. But you have some rare metamorphism, not very many geological resources associated with these, not very much volcanics, but lots of earthquakes. They're a good example of this might be the San Andreas. This is in California, right? Okay, one of the most tectonically active fault in California. Maybe the Alpine Fault in New Zealand. A lot of people in our discussions brought that one up. We have some in I think the Apollonius Fault in Turkey. Okay, these are all some examples of places where we have good transform faults. Okay, so there's not a lot that we're going to be talking about for these ones here, but do realize no volcanics, not very much metamorphism, rare to even non-existent. Geological resources, not a lot going on here. You can have some folds at depth. So remember, faults occur in your brittle deformation. You can have some folds at depth, but it's really rare, and you're not really doing much here. You're having shear folds. And we haven't really been talking about shear folds much here because they're just not very common. They can happen. It's just they're not exposed at it very well. Okay, so that's really transforming. There's not a lot going on for transform. So that was the connection of all these different kinds of landforms. The stuff that we've been basically trying to do for the last couple of weeks in our discussions of trying to talk about these different types of landforms, how folds are related to them, faults are related to them, how volcanoes are related to them, how metamorphism is related to them. We're just trying to get into all these things and connect it together. Okay, now there's more stuff that you can talk about for this for exam, and we can still talk. You still need to have a basic understanding of metamorphism, and I'm not going to go through that in this discussion. This one was just to try to tie everything together, because this is the part of the exam that people have a hard time with, is trying to tie these ideas together. I don't know if that helped. I hope it did. I know that's I talked a lot here, but hopefully this whole diagram works. I'm going to try to probably get a snapshot of this and submit it out to you so that people can look at it. Hopefully you can read my writing. But if you guys have questions on any of these connections, I also put in a key for the discussion that we had last week. Last week we had classes. Last week was spring break. But this is what we're going to be focusing on for the exam, is trying to make these connections. We're still going to be talking about plate tectonics as a general rule, talking about metamorphism. We're still going to be having the same kind of setting or same kind of setup as we did in our last exam. We still have multiple choice, still going to have true false and matching and things like that. But just to remind you of that. Okay. I think that's it for today, at least for this video, and we'll talk to you later.